On this first problem, when you are trying to evaluate a limit at a specified value, as long as when you plug that value in, you do not get an undefined answer, then you have found the limit. So in this first example, it's just a matter of, since you're looking for the limit as x approaches 1, it is simply a matter of plugging 1 in for your x value and then simplifying. And so the limit of this first one, once I simplify, is equal to 1. You'll need to make sure that you at least show me this work where you have plugged in, and then at that point, you can type it into a calculator, but I need to see the work where you have plugged it in. Now, the problem with the second one is when we try to take the x value of 8 and plug it in, that would create a 0 in the bottom of a fraction right here, and that is what we call undefined. So you can't plug it in if it creates a 0. What you look at otherwise is you try to see if something will possibly factor and cancel out. And so what I notice is with this quadratic on top, I can actually factor that quadratic, and when I do, I get x minus 8 times x plus 2. And the nice thing about that is it's going to cancel the factor of x minus 8 on bottom. So then at this point, as you're taking the limit as x approaches 8, it's just a matter of substituting it in for your x so that your final answer gives you a limit of 10. On this third problem, we're looking at a graph and trying to decide the limits. So on the first one, notice they are asking you for the limit as x approaches negative 2, and when you see the plus sign, that's telling you to come in from the right-hand side. So here is my negative 2 on the x-axis. So if I'm coming in from the right-hand side, I'm following this graph to see where it's going to end up as I get closer to my x value of negative 2. And you'll notice in that case, I ended up at a y value that would be equal to 5 when I look over here at the y-axis. Okay, so on the second one, we are taking a limit as x approaches 0, and again the plus sign tells me I'm coming in from the right hand side. So here is where x is equal to 0, so you're following this graph here, and as I get closer to my x equals 0, notice again the y value is at 5, so that would be that particular limit. Okay, on my third one, we are taking a limit as x approaches negative 1, and when you see the negative sign there, that tells us we are coming in from the left-hand side. So here is my negative 1. So I am following this graph from the left-hand side, and even though there's an open point on the graph there, the limit just refers to what y value you're either getting close to or touching. And so in this case, even though there's an open point there, you're still getting close to a y value of 4, so that would be the limit coming in from the left. And then finally, on this last one, we are looking for a limit as x approaches negative 1, and the plus sign tells me that I am coming in from the right-hand side. So again, here is, here is my negative 1. So coming in from the right-hand side, I'm coming this direction. And again, even though there is an open point there, the limit is still what we say at 4. Okay, and so not a lot of work that you can show there. You can kind of trace on the graph. You can, indicate things like, are you coming from the right or are you coming from the left? So, give me some type of work like that so that I know that you understand what you're looking at. Okay, on the next one, you cannot just plug it into a calculator and look at the graph. I have to see a table. So you've got to show me that work to support your answer. Notice that we're looking at x approaching negative 2, and that is telling me I'm coming from the right-hand side. So if you think about a number line, values that are directly to the right of negative 2 would be things like negative 1.9, negative 1.99, and negative 1.999. Now, I don't care if you use a calculator to plug those into the original function, but you still at least need to show me how you plugged them in. So if I take my negative 1.9 and plug it into this original function, notice I get a y value of 152. When I plugged in my negative 1.99, I get a much even larger value of 1592. And finally, when I plugged in negative 1.999, I get a y value that has now gone over 15,992. So that is a clear indication, since they are growing so large, that this particular limit, I would say, is going towards infinity.